Hello everyone, in this video we will learn how to perform basic modeling tasks in ABB Robot Studio, and we will learn how to define tool frames. So what you can see over here is the final result of our modeling effort. Here is our tool, this cone over here, and we will define a tool frame whose center is at the tip or at the top of this cone. So let us start. I will click on File and then I want to start a new station. You have several options here. We're going to choose this option, Solution with Station and Virtual Controller, and here you need to adjust the parameters that correspond to your controller and to your robot. In our case, we have IRB 120, so this is the robot model, and we will click on Create. And it's going to take a while to create the simulation environment. Maybe 10-15 seconds depending on the model of the computer you have. So let us wait a little bit. And then here you will select this option, the first option, and you click on OK. So here is our robot. How to navigate? Pan, if you want to move left or right, you press Control and left click, left mouse button. This is how we pan. If we want to zoom, you use your wheel on your mouse or scroller, zoom in and out. And if you want to rotate, you press Control, Shift, and the left button. So this is how we rotate. We explained this in our previous video. Okay, so the next step is to activate the controller. So I'm going to click here on the controller and I'm going to bring the flex pendant. So here's my flex pendant, and before you start manipulating or moving the robot, you need to activate the robot. So you click on operating mode and you click on a manual mode and you click enable device. Okay, now over here, as I explained in my previous video, you can jog the robot by basically clicking over here and clicking on jogging. So you can move the robot. And if you move the robot, you can see basically now we are in the joint mode. We can rotate every joint. So this is how we move the robot. And this is explained in the previous video, whose link is given in the description below. The first step is to define our tool. In our case, the tool will be a cone. But before we define the tool, we have to make sure that the robot is in some reference configuration. For me, the reference configuration will be that all the joints, the rotations of all the joints are at 0. So let us adjust that. So I can see here that my base is rotated at 12.66 degrees, so I will press this right button or left button to decrease this. And how I know that basically by moving joystick in this direction I will be able to change these values of the first joint? Well, I can see it over here. So this button tells me that left and right buttons are moving the first joint, that is the base joint. So I will set this value to 0, since this is my reference configuration. You can press it and you will get a 0 position. Then I want to make sure that my joint 5 is selected. So how to do that? Well, here by pressing this button you can choose between joints 1, 2, 3 or the joints 4, 5, 6. So since I want to have 4, 5, 6. I will click this button, and then I see over here that the joint 5, here's my joint 5, I need to go down. I need to press the down button or up button to make sure that the joint 5 is in the horizontal position. Okay, now my joint 5 is, or the axis 5 is in the horizontal position. And this is my reference configuration. Okay, so let us model our tool. If I click here, and if I select the modeling tab, I have several options. If I click on solid, I can select box, cone, cylinder, pyramid, and sphere. I will select the cone. And I will enter the following values. So the base center will be at the position 250, 0, 0. The radius will be 25, and the diameter of course will be 50, and the height of the cylinder will be 150. And if I click on create, here is my cylinder. Now you can close this part over here, and if you expand this and if you do a right click, you can change or modify its position, you can change the physics behavior, mirror, etc. Another thing that you can do, if you click on a body, you do a right click, you can set the color. So let us choose the color. Let us choose, for example, the red color. Okay, so here's our end effector or our tool. The next step is to attach this tool to this robot. That is to tell to Robot Studio that this cone or this end effector is physically attached to this robot. So we do the right click and we do attach to, and here we have several options. We have links, right? I can attach it to the basically whole robot structure, base, every link, and I will attach it to the last link, and the last link is actually called the faceplate. So the faceplate is basically this part over here. So I'll attach it to the faceplate in order to show you better. So this is the faceplate. So let's do it again. Right click over here, attach to, and to link 6. And I click on yes. Okay, now we have to now physically move the cone to this point. That is, we first need to rotate it and to displace it. So we can click on part 1, position, set position. Here we will do orientation. We will rotate it first with respect to the y-axis. Here you can see the axis. So x, y, and z. First we have rotation for 90 degrees. And I will adjust over here the position. The position will be 367, 0, and 879. And I will click apply. And here it is. Here is its location, perfectly aligned with the faceplate. However, I found these numbers by trial and error, and you will most likely have to do that while performing your task. This is what I advise you to change these parameters and to play with this number to see how this cone will change. Okay, so the next step is to define the tool frame that's associated with this new end effector. But before we do that, let us illustrate what's happening over here if we do not define our tool frame. For the time being, I'm going to click here and I'm going to select this visible. So that is, I'm going to make this end effector to be invisible such that I can illustrate what's happening over here. Now, what you can see over here is the tool frame attached to the faceplate. This is the z-axis, this is the y-axis, and this is the x-axis. So now if you go back to your teach pendant, and if you click here on jogging, you will see that basically tool 0 is selected here. What is the meaning of this? Now, by clicking over here, we can change the motion mode. We can have linear or reorientation mode. So if you click on the reorientation mode, and we make sure that we are in a tool coordinate system, and this will be tool 0, let's see what happens. Here we have we basically have an issue that the robot is close to singularity. We are going to acknowledge this, and we have to fix that. So how to fix that? Well, we're going to go back to our basically linear mode, and then we're going to move a little bit robot away from its singularity point. Here in this case, linear mode will not work, so we need to select basically the joint mode. So let us change the joint mode a little bit such that we are away from singularity. Okay, now this should be fine. Let us click over here to return to reorientation mode, and let's see what happens. Now, what do we observe over here? I'm noticing the following. My X, Y, and Z positions are not changing. That is, this point over here is fixed in space. The only thing that's changing is the orientation of basically this last segment or the last link. That is, this point is fixed in space and the robot rotates around this point. So this is our tool 0 or tool frame 0. Its position is fixed and the robot rotates around this position. And we can see here that these 4 parameters that correspond to quaternions are changing, and these parameters are defining the orientation. If we want to change the X, Y, and Z coordinates, we will click over here and then we will move the robot. Now what's happening over here and what are we tracking over here? We are basically tracking the point over here. The coordinate system is base coordinate system, meaning that we move in a base coordinate system, and what you can see over here are the positions. These 3 points are the positions of this point, X, Y, and Z. So if we want to go down, this is in the y-axis. If you want to rotate, you're going to move the robot in the z direction, and we can also move the robot in the x direction. Okay, so this is our tool 0. We have defined a new end effector, and we have to define basically a new tool frame that's being attached over here. So the center of the tool frame should be over here. So let's see how to do that. Here, if I click over here, I have several options. If I click on the program data, I can define several variables. Here, I will define the tool data. So what I'm seeing over here is tool 0. And if I double click on this tool 0, I will notice that I cannot modify it. Again, this is the frame attached to the faceplate, and I cannot modify it. So I need to define a new tool. Let's call this tool end effector. We will select its scope. The scope will be global and the storage type will be persistent, meaning that once the program is completed, this frame, tool frame, will be in robot memory. It will be saved. And I'm not going to play with these parameters. I'm going to click OK. Now, here I have an error, and the factor is not a valid name, so I'll probably have to write it like this, since it's a variable. Remember, you can also use rapid programming language to define this end effector. We will explain this in our next video. So this should be a variable name, and there are certain conventions for giving variable names. Click on OK. So let us modify this end effector. We can click Edit. We can change value, for example. Let's see what's happening over here. Okay, so the first and the most important thing for us is to make sure that this tool frame is being displaced from the center of the faceplate, that is, from 0 point of the tool 0 to this point over here. And the offset should be equal to the height of the cylinder. So the offset is 150, since we defined the cylinder with a height of 150. We click on OK. Now, the next parameter you need to adjust is the mass. Here, if you do OK, you'll get an error saying that that mass is not defined. So here I'm going to specify the mass of 1. This is an arbitrary number. However, if you can measure the mass of your end effector, you can precisely specify this number. Why this is important? Well, because by properly specifying the mass, you will make sure that the robot controller takes into account that mass when computing control voltages for the joints. Heavier mass requires more load, that is, more torque to lift. So by precisely specifying the mass, you can basically increase the optimality of your controller. And you click on OK. Okay, so here is our end effector. And what I didn't tell you, that you can also modify the orientation of the, basically, of your tool frame, new tool frame. These are the quaternions, and you can specify the orientation. However, we will not do this in this video. Okay, so let us see what did we achieve by defining this new tool frame. Let's go to our jogging menu and let us do the first modification. Here, instead of tool 0, I can select the new tool frame and I can click on OK. Now, let us go back to our reorientation by clicking over here. You can change from linear motion to reorientation motion, and you can see the coordinate system over here is a tool coordinate system, which is very important. And let's see what happens if I change the reorientation. Remember that when tool 0 is being selected, I'm rotating the robot around this point, but now let's see what happens. Look what happens. Very interesting phenomenon happens. Now I'm rotating my robot around the top of my cone. That is the tip of my cone. Here is what is happening over here. You can see it better over here. Here it is. So for example, if you're welding or if you're performing some task, you have to make sure that this point is always fixed. Okay, so you can also play with other parameters over here. For example, if you click here, you can select linear motion, and here's the tool. You can select the coordinate system to be the tool coordinate system, and let's see what happens right now. So what I adjusted, now I'm moving in a tool coordinate system. Z-axis is in this direction. You can see it over here. Y-axis is in this direction, and X-axis is in this direction. So let's see what happens if I move my robot. Let's move it actually first in the Z direction. So the robot goes in the direction that goes from this point to the center of the faceplate. That is, this is my z-axis. I can see it over here. This is the z-axis. Now I'm moving in the z-axis direction. Y-axis direction should be basically this direction. Here it is. So you see what's happening. I'm basically having here a coordinate system. I will illustrate this by using my Epic pen over here. I like this tool very much. So here's my basically z-axis. This is my y-axis. And this is my x-axis, corresponding to my new end effector tool frame. Okay, so I will erase this and I'm going to deactivate this. I'm going to put it over here so I can use my pointer. So let's see what's happening here. Again, we have defined a new coordinate system being attached over here at the tip of our cone. And now we are tracking, we can make sure that we are tracking this point over here. So when I move my coordinates, when I change my coordinates, I'm basically tracking the point over here. You can reverse this by using the base of the world coordinate system, and what you can see over here, the points are given now in the base coordinate system. The point over here is being tracked in the base coordinate system. Okay, that would be all for today. I hope that you like this video. If you like the videos I make, please subscribe or support my channel. Thank you very much and have a nice day.